Hello, guys. Welcome back again to Diesel Repairs One, DC. And tonight, just would like to talk to you, all of them, about troubleshooting hydraulic systems, heavy equipment, hydrostatic systems, closed loop systems that are used usually on, most of the heavy equipment. It's sometimes it could be a little bit difficult to understand, but once you get the hang of it, it's really not. So, and also, hope you guys are doing well. Thank you for tuning in and being here with me for this session. If you have questions about anything, either if it is engines related, heavy equipment, directional drilling, electrical troubleshooting, also um, semis, region systems, feel free. This is my channel right here, Diesel Repairs One. Once again, welcome. I'm your host, DC, and thank you for being here. So yeah, I'm just gonna start with sharing a little bit of myself. Being on the heavy equipment industry for over 34 years, turning wrenches professionally, and it's my passion. It's what I do for a living, and I love helping people and whatever situation they might encounter that is probably, you know, a little bit difficult to figure it out. And yeah, if you guys ever have an issue and want to reach out, please feel free. I love sharing my knowledge and you know just helping people out. That's what I love to do. So, how about we start? What is a closed loop system? Well, basically, a simple way. Let me see how can I put it in a simple way. All right, imagine two people carrying a bucket full of oil back and forth, right? Back and forth. Two buckets of oil back and forth between two people. So that is the closed loop right there. Imagine a third person with a bucket underneath catching what spills. That's your charge pressure. So basically, charge pressure is what is supposed to replenish what is lost in the hydrostatic system. So why is so essential to have charge pressure on a hydrostatic closed loop system? Well, it serves as different functions, purposes. Cools down, lubrication, and also replenishes. So I have a whiteboard next to me. If you guys excuse me for a couple of seconds, I'm gonna slide it behind me because I like to reach out to basically everybody, and I do understand that people have different ways of learning. Some of us, I should say, learn by seeing images, by writing, by listening, or just by looking. And I don't wanna miss out. I don't wanna leave nobody behind. So yeah, I'm just gonna slide this whiteboard behind me. Excuse me for the noise. Is that the casters on this whiteboard? It's a little bit difficult to move, but I'm gonna try to do my best. All right, so let me see. Hopefully, you guys will be able to see it. Yeah, you'll be able to see it there. And I'm live streaming right here through YouTube and TikTok. So, oh wait, I think I need a marker. And this is organic, guys. This is me talking. I'm not faking anything. This is just me, DC. I know that a lot of you guys are know me in the industry. We have talk over the phone or either DMs or WhatsApp or whatever, and you guys already know me. I'm straightforward, honest, and this is me. You're always gonna get DC. This is me. So I got my hopefully they still work in my eraser right here. So let's say that we're trying to troubleshoot a system on a downforce. Downforce. Let's call it. This is a little bit too dry. Let me get one that is a little bit darker. Give me 1 second. 1 second. So, yeah, that's better. Downforce, either a R90 pump or a H1T, which is also downforce, but this one also comes as a tandem, depending on the configuration. So closest thing to mine on a Vermeer 2022 1620 2330 and other models, they use the H1T. Ditchwich uses also something similar. And so let's talk about the closest example that I can give on an erratic or hydraulic system on a closed loop pump that is working erratic or misbehaving. It could be on a Vermeer 1620, 2022 Series 2, 2022 Series 3, 2330, DRs, also the 2330 DRs, 2440s, Series 2, Series 3, 4055, 3650s, also bigger equipment like the 100 by 180, 100 by 120, 100 by 140, and so on, So every system on those equipment, they have either a R90 pump for your thrust and pullback, and also an R90, the same pump R90 for the rotation clockwise, counterclockwise, and for your mud pump. So basically, you can have 3 pumps, hydrostatic pumps on a 80 by 100. It could be a 75 cc's, it could be a 90 cc's, it could be so the 90 stands for cc's. So it could be a 90 cc, 95 cc's, or 75 cc's, or whatever, pump the manufacturer decided to install on the equipment. On the smaller drills, like the 1620s, 2022s, 2330s, 2440s, 3650s, 4055s, and now they came up with the nice drills, the D24, which replaced the Vermeer 2330, because 2330, they don't make them anymore. So if you have a 2330, that's an excellent drill, very, very reliable. But unfortunately, as the industry changes and high demands and more efficiency, Vermeer decided just to discontinue it and came up with the D24. Also, there's a new version of the I want to say the 2022. I think it's the D20 or D22. I don't remember exactly, but they're excellent. Everything, it's electrical joysticks. You have different buttons on the joysticks, displays. The D24 comes now with a CAT engine, and it's so accessible to work on it. Not as a little bit complicated or hard to, not hard, but you gotta adjust on how to service and work on the 2330s, because the way the engine cover opens, I reminds me of the Lamborghini's doors that they open up. But yeah, it could be a little bit, challenging, I would say, if you're not familiar to work on them. But yeah, there's great drills, and they just came out with the JT. I think it's the 120 or 121. I don't remember exactly, but yeah, they have great drills out there. You know, if you have a JT20, they're great drills. Which also they have the JT 9, JT10, the 922s, JT 922s. The JT25 is an excellent drill. JT30, you can have it on, say, dirt or AT. You know, you can always go back and forth depending. You know, if you have an AT, you're gonna use it as dirt. You know, you can change the pipe configuration with the subsaver. DERs are excellent. Also, for Vermeer makes the 4055 DR, which is, you know, an excellent, powerful drill. Uh, what else? The JT60 from Ditchwich, strong drill, and they're all great. They're all great equipment. You know, it's about, if you own them, how to maintain them, how to understand them, and how to work on them. So basically, it's just getting familiar with the equipment and understanding the way it's supposed to work. You know, um, I compare it to, you know, owning a tool, right? If you have a tool, you should know how to use it. You're not gonna use a wrench. You're not gonna take a wrench and use it as a hammer. I mean, the wrench was designed in with a purpose, just to, you know, tighten or loosen nuts and bolts. A hammer was just to whack the thing out of something, or just drive, you know, a nail or anything else, or just, you know, beat on something. So it's understanding. That's the way I see it. The equipment, right? So um, going back to the hydrostatic closed loop system, they always need charge pressure. So where's the eraser? Okay, right here. So let's talk about the R90s, these pumps right here. That is found, this one, that is found on 2440s, 3650s, and so medium size to the heavier drills. They have its own. These ones, they have its own charge pump system. So on the pump, you're gonna have your hydrostatic system with the swash plate, the slippers, the valve plate, rotating groove, the swash plate, and on the back of the pump, you're gonna have attached to the back of the pump, you're gonna have your charge pump, right? But every pump for the R90, 75, and 95, they have its own relief valve for the charge pressure. So that way you can either increase or decrease the charge pressure on the pump. So if you have, let's say, an 80 by 100 or 100 by 120, you're gonna have three pumps that look the same, but one is gonna be the closest one for attached to your bell housing or the back of the engine is gonna be your rotation, your clockwise and counterclockwise, right? The middle one, it's gonna be your thrust and pullback. And then the last one is gonna be your mud pump. You have a bigger mud pump, that's why it needs, you know, a high flow and bigger hydraulic pump in the system. But each individual one is gonna have its own relief valve, charge pressure relief valve, right? On the I want to say smaller drills like the 1620s, 2022s, 2330s, the 8x10 it's a little bit different. The 1015, it's a little bit different. I mean, as the pump goes, because we're talking about Danfoss, the H1T, and the R90, 75, and 95. But 1015s and 8x12, they use a different pump, same system, same principle, you know, like I just mentioned, they are reliable, and just getting to know them. Okay, so let's talk about something simple, right? Okay, let's start with the R90. All right, let's start with the R90. So On the R90, I just dropped it. Hold on. All right. On the R90, the downfalls R90, right? So let's say this is I'm gonna try to give you a symbol and what it will look like if you're reading the hydraulic schematic. So you're gonna have a line like that, right? And then you're gonna have a square like this with an arrow like this, meaning that this is the engine, right? This is the engine of the drill. And then you're gonna have another square right here that this is gonna be, you know, your pump. Let's say it could be the rotation. So, because it's the closest one to the engine. This thing right here means a shaft. Sorry for the gibberish. I'm going to write it clearly so you guys can understand. Right? Shaft to engine. Attached to the engine. Right? So right here, you're gonna have your pump. You're gonna have right here a let's say you're gonna have back here. I'm just trying to wing it. Not wing it, but give you a simple description so it's easier to understand. Because I don't want to make it complicated. Because talking about hydraulic system, it could be complicated as it is. Just hearing the term hydraulics, be like, oh wait, what? So just to make it simple, right? So this right here, you're gonna have a symbol like this, right? An arrow, right? And then another arrow, right? And then you're gonna have some lines that goes to tank. You're gonna have port A. You're gonna have port B right here, right? You're gonna have port C and port D, right? And then you're gonna have your case drain, another line to case drain. So it depends, it depends on the model, but you're gonna have different lines, different ports, I should say, on the pump, different ports. So this right here, the top one, let me erase this. Let me erase it, make it bigger. So let's say this is the pump, all right? We said that this is the shaft going to the engine right here, right? That's gonna be, this is gonna be your rotating group, swash plate, whatever it's inside here, right? And then you're gonna have a servo, a drawing of a servo, something like this, and then you're gonna have your port A, your port B, C, and D. Right here, somewhere around here, you're gonna have your charge PSI relief. Right here, this one right here. Let's go this one right here. Use a different color. That way it'll be, so this one right here. That's gonna be your charge pressure relief. So the pump is pulling oil out of, let me put it right here, out of your hydro tank, right? Hydro tank. You have lines going to the pump, because it's just pulling oil from the tank. And then as you move your joystick or lever, depending what type of EDC you have, EDC, E, So EDC stands for electronic displacement control. That's what EDC stands for. So you're gonna have your servo, right? This is your servo. That basically just, depending on which direction you want the pump to work, because this is bidirectional. So it can go forward, it can go reverse, meaning that it can spin clockwise or counterclockwise, right? I mean, the depending on the system, right? So let me put right here just I don't know, a rotating group, right? And then this one is your servo. So you're gonna have your servo with either a linkage or with an EDC. So let's say if you have a 2330, 2022 Series 3, 2330 Series 2, and so on, you're gonna have an EDC. 2440As and the previous drill, the older drills, they do have, a linkage. They don't have EDCs. Because, from the joystick, there's a cable going down to the pump, and then, as you go forward, reverse, then the swatch plate is gonna move. It's gonna neutral position, right, like that, and then the swatch plate, depending on the servo, moves the servo. I should say the servo, depending on the movement, it's gonna go either this direction or this direction, and then your no direction, the swatch plate is neutral, like that. I wish I can have a rotating group on hand so you guys can see it, but it's a barrel with 9 slippers, nine pistons, right? And they are perfectly machined with the I think it is a brass insert inside the barrel. That way, you can lubricate and don't lose any oil and don't have any internal leakage. You're still gonna have some, right? But we're gonna talk about it, why it's essential to have charge pressure and how you can detect it and make the necessary adjustments. So yeah, that's neutral. And then as you move the EDC, it can go the swatch plate this way, right? Or the other ways. So you're gonna have an inclination. It can go from here to here, right? And then back to neutral if you let go of the joystick. And then if you go the opposite direction, it's gonna go like this, right? And that's what sends either pressure to A or to B, depending, right? Because this thing is gonna be moving a certain direction depending on the movement of your joysticks. Right here on the R90s, we're talking about this drawing is for the R90s, 95s, and 75s, right? This right here, these small squares, this one, and this one, right? They are called multi-function valves. All right. So let's say the pump is designed, from the factory to put out 6,000 psi. Right? You want to put out 6,000 psi. 6,000 psi. Right? So this one, right, and then this one, 6,000 psi, right? So the multifunction valve looks like a cartridge, Well, basically it is a cartridge that goes inside the pump. They are adjustable. They are adjustable. So let's say if you have an operator that loves to, ram the joints as you're making up threads or anything like that, and you don't want your equipment to be abused. Some people, which I totally get it and understand, because rods are really expensive, depending, you know, what type of rod, if it is a fire stick or whatever, they're really expensive. It's a lot of money, right? Per rod is a lot of money. So I get it. Some owners are like, no, you know what? Since we're gonna be working certain type of soil, ground, decrease the pressures for me, right? So that way the operator doesn't go crazy, or he's trying to understand the how the equipment works. I don't want him to be slamming on the rods, or just going crazy because I want to protect the threads. Well, I understand. Yeah, it's okay. So this ones, right? They do have in the middle a jam nut, right? A jam nut, and this one too, and this one too. In the middle, they do have an adjusting screw. It's like a set screw, right? If you want to decrease your forward, let's call this one forward, forward pressure, forward. Oh my God, I can't write tonight. What's going on? Forward. Let's call this one port A. Forward. Let's call port B. Reverse. So if you want to decrease your forward pressure and reverse pressure, to 4,500 psi, my suggestion, and also Danfoss tells you to go up here. You're gonna see on the on top of the EDC right here, right, and also on certain ports on the pump. You're gonna see certain places that you can put a hydraulic gauge, so you can get readings, straight from the pump. But also you can you can tee off out of port B, right, with a gauge, and on port A also you can put a T with a gauge. Even though you're gonna see it on the operator console, because your pressures for forward and reverse, you're gonna see them on the display. If you have like a Series 3, 2440 or 3650, you're gonna have a analog gauge with a glycerin fill, and you're gonna see it. But I always go straight to the pump, because let's say the system has been contaminated, and maybe there's a small obstruction on the lines that is gonna give. I don't know if it is gonna give me an accurate reading, even though newer equipment has a what is called transducers. So basically, it's a sensor, right? A three-wire sensor, because you gotta have your power, ground, and signal, right? On a shuttle valve. Shuttle valve means that it's a valve. Put a different color. It's a valve. Oh man, try it up. Thank you. I'll throw it away. All right. So shuttle valve, it's basically a square valve, right, with a ball inside. Think about a steel ball from a bearing, right? So you're gonna have your line in, and then you're gonna have your line out, and right here you're gonna have, just to read pressures, right? So you have your shuttle valve, this one right here, and this is your PSI transducer, right? You gotta have three wires. You're gonna have your ground, power, and signal, right? Because you gotta see, so you can translate basically the hydraulic pressure into a electrical signal, and that's how you get your reading on your digital display. So, but even though, oh, and this shuttle, this bearing moves. So let's say, if you're going forward, it's gonna move this ball this way, blocking, right? Or it's gonna move this way, blocking. Why? Because when you're going forward, it's gotta block the other port, so you can get a reading on your pressure transducer. If not, you know, not gonna get a reading. You're not gonna get an accurate reading. So, I get it. Equipment, sometimes needs to be serviced on the field. Cannot be taken back to the shop because it costs time and money, and time is really valuable. And sometimes the equipment needs to be fixed on the field. I get it. It's understandable, right? But unfortunately, it happens. We're human. We're not perfect. The service technician can be working on it and replacing filters, and then he drops the brand new filter. Got full of dirt. Gonna try to blow it out, or if he has a air compressor on the truck, he's gonna try to blow out the dirt. Just driving that dirt deeper into the filter, and it turns and then put it back in, and that dirt's gonna loosen up and go somewhere, and then catastrophe. Something might get blocked off, and might gonna start, and so on. So that's why I always like to go straight to the pump with a digital pressure gauge. Digital gauges are precise. They're not really expensive. You can get really expensive ones, but you can get ones for a reasonable price that is gonna do the same thing. I always use up to 10,000 psi gauges, right? Because I mean, if you see this pump right here, puts out about 6,000 psi, right? And yeah, you're gonna have internal relief valves, um, but you never know. Never know what type of equipment or hydraulic pump you're gonna be adjusting. That might be like, man, you know what? My pressure gauge only reaches 3,000 psi, and this system, puts out 5,000. Then I don't recommend you putting, a 3,000 psi on a 5,000 psi system, because you're gonna damage the gauge, and then you know you can get hurt. So hydraulics, they are complex. Respect them, because they can do a lot of damage, especially to the human body. So safety first. Also wear your proper PPE, your safety glasses, gloves, and whatever. Always expect the unexpected. But if you understand it, know where to go, you're gonna be okay. So yeah, some people say, you know what, just lower the pressures because I want to protect my equipment, or just they're driving down too fast, depending on the type and model of equipment that the pump is mounted on. You know, so yeah, they might say, you know what, just lower the pressure. So all you gotta do, put a wrench on the jam nut, loosen it, and then you gotta hold the jam nut on the multifunction valves. And if you want to decrease the 6,000 psi, you gotta go counterclockwise, right? Losing it. So if you back out the set screw, you're dropping pressures on this style pumps. If you tighten it, if you go clockwise, then you're increasing the pressure. So keep that in mind. What is it that I call it? Lefty loosey, righty tighty, something like that. So same thing with the multifunction valves. Once you have your desired pressure, then you gotta hold in place the adjusting screw or the set screw on the multifunction valve and tighten the jam nut. That way, the set screw is not gonna back out with vibration or whatever, or the jam nut with vibration is not gonna it's not gonna get loose and then you drop it on the ground and then it's gonna start leaking, because they do leak. If you don't adjust them really tight enough, they do sip out a little bit of oil. So why is essential to have charge pressure on your system, right? This pump right here, like I mentioned before, this is the one. Yeah, like I mentioned before, on the back of it, you're gonna have your charge pressure mounted, your charge system. You're gonna have eccentric gears back here. That is your charge pressure pump. This one right here, it is attached to it, right? Keep in mind, they do have a pin. If you disassemble one, you're gonna see right here. Let me use this, a pin. Actually, two holes, right? One here and then one here. If you're working on a R90 or 90R pump, keep in mind the position of the pin. I'm gonna show you, because then you're gonna do all that work and then you're gonna be asking yourself, what went wrong, what I did? And then you gotta disassemble everything, because putting the system back to work takes it's a process. It is a process, and assembling everything, putting back the old back on the system, and then you're like, what? Why is not working? Right? Because this is the let me do right here. Let's say we're looking at the back of the pump, right? There's a socket, Allen head screw here, another here, and then right here is where your charge gear pump goes, right? So there's a plate. If you look at it, you're gonna have a pin here, right, and a pin here, something like that. If you disassemble the pump and your pin is right here, make sure you put it back where it was. So if you're working on a pump that rotates to the right and the pin is here, make sure you put it back where it belongs, right? Because if you put it here, you're gonna have issues. You are gonna have issues, right? So if you put the pin on the wrong spot, you put the pin right here on the wrong spot, you're gonna have issues. You are not gonna have charge pressure. You're not gonna have charge pressure, because you might think that, okay, you know what, you just change the configuration. Also, the pump uses a plate between the rotating group. Rotating group looks like something like this, right? And it has the slippers all around that go through in, right? It's got 9 of them all around. So imagine the best description that I can give of a rotating group, a 38 revolver. It has the barrel and the holes for your pew, right? So right here is where you have the slippers or the pistons. The middle is where the shaft goes, shaft of the pump, right? But up here, you have the Schwarz plate. This thing runs on the Schwarz plate right here. The pistons, they move on the Schwarz plate. Schwarz plate. All right. Here, over here, You have a valve plate. This is your swatch plate, rotating group, and pistons or slippers, whatever. Here, you have a thin plate, a very thin plate, right here, on the back of the rotating group. So, if you look at that the plate, this plate right here, keep an eye how you put it back, because it's like this, right? It's got a slot, and then it goes like this. It's got another slot, and then something like this, right? My drawing is probably not gonna be as accurate, but you know, they're pretty close. They're pretty close. I wish I could have those parts, you know, with me so I can show you and you get a better description or idea. But if you've been working on this or are working on this and you're having issues, you can relate. You can be like, ah, yeah, I know what that is. I know how it looks like. So you're gonna have some passages of oil around here, right? And we're talking about the 90R, right? Here, you're gonna have an arrow. Here, you're gonna have an arrow. So make sure if this is a right turning direction pump, make sure you put that. Make sure you put those components exactly how they were. Because if you put this plate the opposite, then you're gonna have issues. You're gonna have issues. Because if you change it, instead of the pump pulling oil, instead of the pump, this is the tank, pulling oil from the pump, right? It's pulling oil from the pump. It might be doing something different that you're gonna be hearing a weird noise and be like, why I don't have pressure? Why is the system not working or not, you know, reacting? Because there's something that it was probably installed incorrectly, right? Because it tells you, if you look on the downforce pump label, you're gonna see a whole bunch of numbers and letters. And that decal, it could be a decal, it could be a stamp plate on the housing, is gonna tell you, okay, it uses this shaft with 14, it's a 14 teeth spline or a I don't know, a 20 teeth spline. Uses this style of EDCs or control valve. It uses either a different types of multifunction valves, and it's basically a description. So whenever you gotta order parts, you go by that. Make sure you go by that information, right? Because the manufacturer, when they put the pump together, they say, okay, this is what's inside this pump, and this is how this pump is required to have to work properly. If you put something different, then you're gonna have issues, right? So just clean surface, clean table, disassemble everything. And what I do before I disassemble a pump, I clean it out, the outside housing completely. I capped off everything. If I disconnect the lines from the pump, I'm gonna cap them off, the ports. That way, when I wash it, I don't introduce any foreign material or contamination into the pump. Yeah, the pump might be damaged, but then if I don't do that, I might miss why the pump failed, right? So basically, if I want to do a clean, thorough inspection, throughout my years of experience, what I do, I remove the pump from the equipment, clean it completely on the outside, then start working on it. I have, you guys can, do it your own way, but I have on my tables, those baking sheets, aluminum big industrial baking sheets that they use on the bakeries to cook to bake cookies, pastries. That's what I use because it's a tray that, yeah, when I remove the pump, I already lost some oil, right, in the process. So after I clean it completely and open it on top of that baking sheet, just a little bit of oil is gonna come out. And since everything's gonna be clean, I can be like, okay, I see why it failed. It failed because it was worn out, because one of the swash plate bearings got damaged. It broke because maybe the spring on the servo failed, or it failed because he was starving of oil, or because the one of the slippers or pistons broke off. Because this thing right here, this is all metal, but the head, the slippers are brass material. Swash plate, metal, right? The only thing that is brass is the head of the slipper or the piston. It's okay. You can call it piston, you can call it slippers, whatever term you use, so you can remember, it's okay. If you want to be technical, call them slippers, yeah, hey, it's acceptable. You're the mechanic, you're the one that understands it. So that's what I do, right? And I also have some clear, transparent oil drip pens. That way I can catch all the oil, the remaining oil from the pump also, and put it there. And once the oil settle inside that clear, transparent oil drip pen, I can see, did it fail because of foreign material? Did it fail foreign material as dirt, rocks? I've seen rocks. I've seen glitter from maybe a hydraulic motor that blew up, or just broken up and then ended up on the pump. I can see different symptoms or different causes, that cause the pump to fail and, needed to be repaired, rebuilt, or, whatever. I rebuild them. That's what I do. I rebuild pumps. And basically the whole equipment. I do equipment from the ground up that has been on accidents, rollovers. I strip down the equipment down to the frame and then put it back bolt by bolt. Just me, myself, and I. I'm really proud of it, and yeah, I have a lot of passion for what I do. I'm not just a simple parts changer. I don't consider myself that. I like to go to the root of the problem, right, and fix it properly. No shortcuts. When I'm tackling something, if it is something simple or something as rebuilding whole equipment, my followers, people that know me, know that I'm talking the truth. They've seen my work, and I'm just not, blowing smoke. That's my passion. That's what I do. And yeah, I like to go straight, straight to the system, go deep, and be like, oh, okay, this is what happened. Was it because of lack of maintenance? Okay, lack of maintenance. Was it because, a mechanical failure of a other component? Okay, it's easy to determine, if you have a clean area and you follow step by step, but doing pumps on a contaminated area like dirt on the floor, on a dirty workbench, nah. I strongly suggest don't do that. Don't do that. Be clean, be thorough. That way you can see better. If you got to use a magnifying glass, use it. Why do I say that? Why do I say that? Not because, you're trying to be Inspector Gadget or, Sherlock Holmes. No, no, no. It's because the swash plate, on the hydro pump has four puny holes that are for lubrication. If you're not thorough inspecting the pump, you're gonna miss if those holes are blocked off, caused by, shavings, glitter, or foreign material contamination. Then you're gonna put everything back together, and what happened? Oh, it fell again. Was it, because part failed? No, because probably you didn't do your work thoroughly. I'm being honest. I'm being honest, guys. I'm being honest. If you take your time, I know that time, is an essence, but when it comes to this, I mean, sometimes you gotta disassemble a whole machine to remove a pump, and to put it back together carelessly. Then you gotta scratch your head and look funny in front of the owner of the customer or everybody else and be like, "Oh no, I don't know what happened." Well, something happened. All the parts are new. Most of the parts, because I rebuilt, and some of the parts on a pump you don't need to buy new, depending on the condition. You can save them. For example, if the slippers are okay, you can reuse them. Just lap them. Lap the head of the slipper, the brass. Lap the swash plate, the bob plate. It's not when I say lapping, it's a process, right? You gotta use what I call a perfectly well, what I call no, it's called a perfectly flat surface, a machine surface, right? That is not gonna lie. You can use, and that's what I have. I have a machine flat surfaces that they are used to rebuild this. Closest thing to that, I want to say certified granite block stone. Certified meaning that it's been inspected and is true flat all the way. Don't use a piece of plywood. Don't use a table. No, no, no. You gotta do it right. Because lapping it means that you're resurfacing, you're fixing the imperfections, right? Bringing it back to life. And when you do that, it needs to be on a perfectly flat surface. Do not use sandpaper. No, no, no. Do not use those sponges, Scotch Brites. No, no, no. Use the proper equipment. You can use different things or tools or lapping compounds, I should say, that is for this. Don't go crazy. No, no, no. If you're gonna open up a hydro pump, put it back together, the way it's supposed to, right? Because I've seen videos out there. I'm being honest. I'm like, wow, man, that's crazy. That is crazy. If you're gonna do this, if you're gonna go through this process, when you're ready to assemble the pump, right? Just lap it. Make sure you do it properly. Expensive? Yes, it is expensive. Acquiring that equipment. But it's gonna save you time in the long run. You're gonna know this was done on a professional way, completed, and I know it's not gonna fail. But if you don't do it right, well, you might have the equipment back in a week or maybe the next day, because maybe you didn't lap it. I've seen videos out there that, They put the pump on the floor, on the dirt. Yeah, I'm gonna clean it. This is what failed. You haven't even opened the whole pump, and you're already saying this is what failed. You don't know if a piece of a thrust motor travel all the way or somewhere, destroying the pump. Oh, and they no, this is what failed. What? Go through the whole system, go through the whole process, identify why it failed, open the whole pump, inspect every single piece, every single component, and be like, okay, wait, everything is here intact. And ask yourself, what caused this pump to fail? Was it lack of, if it is lack of lubrication or overheated, you're gonna see it. You're gonna see it right away. Right away, you're gonna see it because you're gonna see heat marks. You're gonna see heat marks on some of the components. You're gonna see if it was water intrusion because you're gonna see rust and you're gonna see traces of water right away by opening a small section of the pump. Oh yeah, this is what broke. No, to be honest, I'm like, what? Really? Those everybody has their own way. I'm not here to compete with nobody or think that I'm superior to nobody, because I'm not. But my over 34 plus years of experience doing this heavy equipment, hydraulics, troubleshooting, and all that, I take it to heart, especially when it comes to fixing equipment, because it's my name and my line and my reputation on the line. No. If I want an equipment, if I'm going to fix it, I want to make sure that equipment doesn't come back with the same issue. If it comes with a different issue, that's another story. If I rebuild the hydro pump and then the equipment comes back because now there's a cylinder leaking, that's different, because maybe the rod seals were so worn out that it just started to leak. Excuse me, I'm gonna ask my moderator. I got a message on my phone to see, because I don't want to lose my live feed on the TikTok. So they can take care of that. So yeah, I make sure that when I send an equipment out, it doesn't come back with the same issue. No, if it came back because one of the boom cylinders now is leaking, okay, well, let's see what happened. You know what? Cylinder seals were worn out. But you gotta make sure you inspect the pump, and you gotta make sure what caused the pump to fail. And this is not about doing it quick and yeah, here you go, is your equipment back? Because the owner of the equipment is already probably losing money, most likely losing money, because now has one equipment that is down, and he's still got to pay a crew to work plus his expenses. And now you're gonna do shortcuts and crazy stuff. You're gonna take money, they're gonna pay you, and then the equipment comes back. Hey, fell again. So do the process, do it nice, neatly, clean, inspect everything. If you gotta use, like I said, magnifying glass, use it so you can see. Right? There's nothing wrong with that. No, use them. So that way you can identify, hey, wait a minute, something traveled through the hydro system, ended up on the pump, boom, destroy the pump. Or water intrusion, foreign material, dirt, whatever, you can identify it, right? But whenever, the system fails, yeah, I rebuild the pump. And let's say if the ball plate, which is made out of brass, has a brass coating, it's to destroy, hey, it needs to be replaced. If I can lap it and bring it back to life, yeah. And then I gotta measure everything, that my tolerances, are not off. because if I had too much, I'm gonna have internal leakage. Leakage is gonna be, yeah, it's gonna be working, but not as efficient as it's supposed to, right? So I don't only concentrate on this. Yeah, all right. I'm like, okay, yeah, okay. I see that the pump failed. Okay, rebuild it. I did my inspection. Oh, okay, wait. It wasn't caused by the pump. There's a piece of something of steel that either came from a gear pump or it came from somewhere, ended up destroying the pump. So now, before I install the pump back into the equipment, I flush and clean every single hydraulic line, even the coolers. Everything needs to be cleaned out. Even the tank needs to be cleaned out. Everything, the strainers inside the tank, pull them out, clean them out. If they gotta be replaced, they gotta be replaced. You know, but saying no, yeah, it's the pump. Yeah, pump failed. Boom, bam, put it back on the machine. Hey, wait a minute. What happened with the metal shavings that got trapped in some of the valves or some of the lines, or anywhere else? They're gonna end up and destroy the pump or something else. So when it comes to a catastrophe like this, that the pump, boom, something ended up in the pump and destroyed the whole pump. Before I install the pump, I flushed everything. And believe me, you're gonna find a lot more stuff in the system. So yeah, when you do this, make sure you do it, and clean it completely. Don't cut corners, because now parts for pumps, say before we're just an example, before we're like $400, now they're like $2,000 a part, not the pump. The whole pump probably was maybe before, I don't know, 2,500, maybe 2,000 the most. Now it's like almost crazy, like almost $9,000-$10,000 for a whole pump. But remember, if you buy a new pump and you put it back on a contaminated system and you destroy the pump, don't expect any warranties. Don't expect any warranty. You're gonna be okay. You know what? There's no warranty on this. It's on you. And now you're gonna tell the owner of the equipment, hey, you know what, man? There's no warranty. They're not gonna pay for it. Of course not. It wasn't their fault. It was your fault because you didn't clean the system. So either if you buy a new pump or rebuild the pump that you're working on, clean the whole system. Use good filters, because using good filters also helps keeping the pump running and keep up with the maintenance, with the manufacturer suggestions. If he tells you, within 250 hours, this needs to be serviced. Within 500, 1,000, 2,000 hours, 3,000, 5,000 hours, whatever, just follow the maintenance. And also keep in mind the hydraulic system needs to be replaced. Hydraulic system is not meant to last forever, because also as time goes, it starts losing its lubricity, its lubrication properties. So hydraulics oil is not meant to last forever. It's got its lifespan. So that's something you got to take in consideration, right? So why does the pump needs charge pressure? So the pump needs charge pressure to replenish, right, what is being lost as the system is going. So like the example I give, closed loop, you had two guys passing back and forth a bucket full of oil, right? In the process, some of the oil gets spilled. There's a third person on the bottom catching the oil that gets spilled, then replenishes. That's charge pressure. And also you need charge pressure because it's easier to the pump to be able to work right away, because you're maintaining a constant pressure on the pump and supply. So let's say if you want to move the machine forward, your pump already has charge pressure that is going to be able to react, as you command. It's going to keep it lubricated. That's why you need charge pressure in the system. So let's say this pump calls out for let me put this 375 psi of charge pressure. This is on a 90R or R90. I don't remember, to be honest with you. I'm kind of a little bit foggy on the head, but I'm trying my best to explain things. So this is your relief charge relief, right? So this pump right here calls out for 375 PS of charge pressure, charge pressure, right? Manufacturer downfall says this pump needs to have 375 psi as charge pressure. Let's say your system is a little bit sluggish, or you notice that it's not working properly. Try, since this pump has already a charge pump attached to the back of it, try to increase the charge pressure on this to see if this number changes from 375, I don't know, to 400 or 380 or 390, right? Because sometimes, as the equipment works, things wear out. So if you gotta bring back up the 375 and you're getting 350, your gauge inside the operator's console is telling you, oh, I'm just putting out 350, and it's calling for 375, go to the charge relief valve, charge pressure relief valve on the pump. Just adjust it. Remember, clockwise, you increase the pressure. Counterclockwise, you decrease the pressure. So try to adjust it and see what happens. Of course, with a gauge attached to the pump, to the charge system. That way you can, see, okay, you know what? It's increasing, right? So you were getting 350, calls out for 375. Now you adjust it and you're 375, and then it bounces back and forth from 375 through 385, 384. Let me put that number out there. That's okay. Precise, it might not be, but within that range, right? Okay. All right. That's excellent. Yeah, that's excellent. So that, maybe your the seat it could be. I'm not saying that it's always, but it could be that the seat inside the pump for the relief valve maybe is worn out, because oil goes through there, right? As oil goes through there, it causes friction, heat. They tend to wear out, right? Another thing it could be, I'm not saying that it is, it could be. So you gotta see a bigger picture. Do not concentrate only on one thing. When you're troubleshooting, ask yourself, okay, wait, what controls the charge pressure? I have a relief valve, and I have a charge pump, and I have this and that. Always, if you gotta break it down on a sheet of paper, okay, this is everything for the charge system, right? So if you see that your pressure increase from 350 back to 375 or 384, that's okay. So it could be that this thing is getting worn out, but also it could be that the gears right here are starting to wear out, like the oil pump on an engine, right? You see that on a brand new engine on a car or on a equipment, you get a high constant oil pressure. I don't know, let's say 80 psi. As the engine wears down, the oil pump also wears out. And instead of being 80 psi, now you're getting 50, right? So you got to take in consideration, is it the relief valve, the cartridge? Is it the gears for the charge pump? So you got to also think about those components, I should say. And but what will happen if you keep increasing, adjusting up, adjusting clockwise the charge pressure and nothing happens? Well, maybe you have a bad charge pump. Maybe. So always use a gauge to determine why it's happening, how it's reacting. So basically, you're seeing behind the system by putting a hydraulic gauge. You're seeing behind the system. You're seeing live data. So that's why you always need charge relief on this style pump. Now, let's talk about a different pump. The pumps that are seen and used on the Vermeer's 1620s, 2022 Series 2, 2022 Series 3, 2440, 23. I'm not 2440, because the one that I just explained was 2440. So let's go from 2330 and down, right? 2330 Series 3, 2022 Series 3, 2022 Series 2, 1620 Series 2. So they use what is called a tandem pump, right? So you have a pump right here, right, for your clockwise and counterclockwise. Attached to it, you have this is gonna be, wait, hold on. This is gonna be the middle section, right? Should do it like this. You're gonna have your middle section, and then back here, you're gonna have your thrust and pullback, right? This pump right here, you're gonna have a relief valve. Let me use this color. Make sure that this is not the right one. Back here in the middle plate, on the middle section, you're gonna have your relief valve on those specific drills, except for 2022 Series 2 and 1620s, that the relief valve, because of the position of the pump, the relief valve ends up on the top. Only the 2330 and 2022 ends up on the bottom, right? Because of the position of the pump, the way it's mounted on the machine. This tandem pump does not have charge pumps like the previous one that I taught. On the 2330s, you have, let me do this. This is gonna be your engine. On the front of the engine, underneath the alternator, you're gonna have a double gear section pump, aluminum housing. One section is gonna supply oil to your fan, engine fan. The other line is gonna be the one supplying oil for your charge pressure. So this is a double section gear pump, this one. Right here. Right? That's gonna be your double gear section gear pump. So if you see, you're gonna have your supply line that sometimes is really funny to work on because you have the alternator so close to the pump, and between the pump and the bottom of the alternator you have the supply line, right? That basically just pulls oil from the tank, from the hydro tank right here. Sometimes it's a little bit uncomfortable and funny to work on. So this pump relies on this small pump for charge pressure, because behind, attached to this pump on a 2330, you have another pump that is for your, we said that this is CCW, thrust, pullback, and this is your mud. Right. And this is your mud pump. Right? This pump has its own charge pump. This one, your mud, but not the tandem pump. The tandem pump, this one relies on this small pump. Right? So once again, on 2330s, they call out for between 350 to 375 psi of charge pressure from here to here. This pump right here needs a constant charge pressure between 350 and 375. I think the latest revision, it's 375, if I remember right. It's 375. So if on your display you're reading that your low on 350, I'm gonna show you something. I'm gonna show you something that you're gonna be able to do. Okay, so we got this, right? Tandem pump. The first section, closest one voltage to the engine, is your clockwise, counterclockwise, and then your thrust. You have your middle section, and then your thrust and pullback, and then your mud pump, and then the tandem pump only relies from oil from the double gear aluminum pump that is mounted in the front of the engine, bottom of the alternator. You're gonna see it. You've seen it because remember the pump that is underneath the alternator that always these fittings right here are leaking because they get over tightened. There's still fittings, and they go crazy tying the fitting on an aluminum housing that they end up cracking the housing, the threads where the threads are, right? That's why they leak. That's why I said if you gotta use a magnifying glass, use it, because they think, oh no, it's the O-ring, because it's a Boss O-ring, meaning let me erase this. Meaning that, oh, you know what? Let's say this is the pump, the double gear pump, right? So fan, right? Fan, and then charge PSI to tandem pump, right? Then you have a line that goes here to the fan, then another here to goes to your tandem pump. This fittings, right? This is aluminum, all aluminum. This is all aluminum. 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 I think I spelled that correctly. Maybe not. I hope so. My moderator is nodding her head saying, yes, you got it right. Thank you. All right, so this is all aluminum, right? You have Boss O-rings, JIC, meaning that this is your threads, right? Let me do it like this. Yeah, this is your threads. That's the threads of the fitting. Right here is where you put your wrench, right? Where you put your wrench, and this is your fitting, right? With threads, JIC. They say, no, it's leaking right here because the O-ring that goes here went bad. And it's leaking. Ah, you see that it's flat? Yeah, it's leaking. But you replace the O-ring, it keeps leaking again. And then you replace the O-ring, it's leaking again. And then, no, let me tighten it. They go crazy tying this fitting right here or right here. And it keeps leaking. All you gotta do, if it is leaking, inspect the O-ring. Well, the O-ring doesn't look too bad. Oh, okay, you know what? I gotta pull the pump. You gotta pull it out, unfortunately, because you gotta see the hole where the fitting goes if the threads are cracked. You're gonna see a hairline crack. Let's say this is the hole where the fitting goes, right? You're gonna see a hairline crack that goes all up into the housing. And that's why your pump keeps leaking. Not because of an O-ring, it's because somebody going crazy over tightening the fitting. And now you gotta replace the whole housing, or the whole pump. You gotta replace the whole pump. And that's the simplest thing. You know, just do your inspection and make sure that, you know, that is not the housing that is cracked. It could be the O-ring, but you keep changing the O-ring. Ah, let me go, you know, tighten it even more. All you gotta do, pull the pump and see, make sure it's not cracked. But this pump, this aluminum pump, like I mentioned, it supplies oil to the charge pressure on the tandem pump. On your display, you're gonna see, I'm gonna do it like this, right? Like this. You're gonna see 0, let me say 1,000, I don't know, 2,000, right? 3,000, and then let's do 6,000, right? Same here, 0, 1,000, 1,000, 2,000, 3,000, and 6,000. All right. When you have the engine running at idle, no functions running, you're gonna see right here. Let me use this color because this is the actual color. You're gonna see a reading on green, right? On green. And you're gonna see this one, the same. Let's say this is, wait, hold on. You're gonna see green. Right? That's a bar. You know, as you move the joystick, it's just basically a digital display that you can read PSI, right? So this green reading right here, that's gonna be at idle. At idle, you're gonna see right away pressure. So if the system goes out for 375, right? As for charge pressure, it's for both right here and also right here, because you only have one pump supplying oil for charge pressure on the tandem pump. 1. So that's why the 375, you should see it right here and right here. Once again, this is your rotation, and this is your thrust and pullback. You should see this, all right? Or maybe a little bit lower because you're at idle. Let's do 280. 280. And the system calls for 375. This equipment has to be adjusted, the charge pressure on all verniers, all day twitch, American augers, and basically, they all have to be adjusted at high RPMs, high idle, because that's how the machine works. The machine works on high idle, doesn't work on low idle. So if at low idle, you see this, it's okay. It's a low idle, but also depending on how many hours on machine. If you have a machine with 100 hours, you're gonna see a different reading than a machine with 3,500 hours on it, right? So let's say idle, you're seeing this. Okay. Now what happens when you put the engine on high idle? You bring the engine on high idle. No functions, nothing touching on you're not doing anything. All you did, increase the RPMs on the engine. That's all. You're not, you didn't enable it hydraulically, nothing. You just seeing that, right? Fire the machine, let it warm up, bring it up, high idle. If this number doesn't change to what the manufacturer recommends, to 375 like here, 375 right here, right? Then you gotta start adjusting things. You gotta start adjusting the relief valve on the pump. See, if it increases, if it doesn't increase, then you gotta start your troubleshooting. But let's say on this one, on low idle, you're getting 280, and this one, you're getting, let's say, 295. Yeah, 295, right? But then on high idle, you get right here, 375. And on this one, you're getting 420. How can I make these two pressures be the same? Because you only have one relief valve for the tandem pump, but your rotation is reading 375, and your other gauge on the display is reading 420. There's certain things you gotta take in consideration. Is my pressure transducer reading correctly, accurately? You gotta ask that. That's why always put a gauge on it, because you can detect, oh wait, is the pressure transducer giving me a false reading that I'm seeing on the gauge, 375 here, right? Like I'm seeing here, but here is giving me 420. Okay, so I most likely have a faulty pressure transducer that is giving me incorrect reading. Simple, right? But you put the gauge on the shuttle valve for the pressure transducer of the thrust and pullback, and you see the same pressure that is telling you on the display. Okay, then it's not a faulty pressure transducer. It's not a faulty pressure transducer. So how can I lower this pressure to be the same as this pressure when you only have one relief valve on the pump? for both systems. Simple. Let me erase this. On your, use this one. On your tandem pump, all right? You're gonna have right here, you're gonna have right here 2 EDCs, right? And this is the pump. This is the pump. This is the middle section, right? This is the pump. It goes here, 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 right? And this is your middle section. This is where your relief valve is gonna be on this middle section, but on the bottom, right? If you're looking at when you open the engine cover, you're gonna see the engine right here, and you're gonna see the EDC looking at you. EDC looking at you, right? These are coils. These are coils that they have wire connections going to the pump control. So this is rotation. This is thrust and pullback, right? On the display, this one is giving me 375. And this one is giving me 420, a high idle. Do I mess with the relief valve? Do I mess with the relief valve? No. Because if you mess with this, you're gonna affect this pressure and this pressure, because you only have one relief valve for both systems. Don't even touch it. Don't even look at it on the relief valve. Concentrate only on the pressure that you gotta work on. You already know that the front section of the pump is giving you what it's supposed to have, right? So you already take that out of the picture. Because I'm saying that because sometimes we get overwhelmed and we start touching things, and then we, do more harm than fixing. On the EDC, on this EDC, you're gonna have a plug in the middle with an Allen hole. Basically an Allen, you need an Allen key, Allen wrench to remove the plug, right? Then on the other side, next to it, I think it's gonna be on this side. Yeah, it's gonna be on this side. On this side, you're gonna have a jam nut with a set screw in the middle. The only one that has a jam nut right here. All you gotta do, if you want to bring down this pressure from 420 to 375, grab a wrench, a 13 millimeter, 13 mm wrench, and I think it's a number 6, a 6 mm Allen. I think it's 6 or 4. I think it's 6. Yeah. You're gonna hold the set screw and you're gonna loosen the nut. A high idle. This needs to be done at high idle because that's how the machine works. A high idle. Keep that in mind. Right? Once you loosen the jam nut, loosen the set screw, and you're gonna see how this pressure is gonna start decreasing, equalizing to this pressure of the front section. That's all you gotta do. Why? Because remember, this section of the pump, inside, let me put it, how can I draw it? Okay, so you have the swash plate. You have right here the rotating group, right? With the slippers. Right here on the, this is the swash plate. Right here, you have a control pin, right? It looks like it has a bowl on the top, like a pyramid, maybe something like this, right? Something like this. Might not be too accurate because sometimes, my drawings are not the best. But right here, right, this is looking at the internal of the pump. Right here, it's where the EDC, this thing right here, is this thing right here. Right here, right? So it's attached, I should go lower, it's attached to the inside of the EDC. Right? So when you loosen this, you're moving the swash plate. Maybe your swash plate was inclining. It will stroke basically to out of neutral a little bit. It's not gonna reflect on the thrust and pullback. Maybe your carriage is not moving by itself, but it's enough to throw off your charge pressure. That's it. It's enough to throw off the charge pressure, to increase it. Now, when you loosen the set screw for the control on the swash plate, you can spin that thing 360, and it's not gonna stop. You're not gonna be able to pull it out. Why? Because it's basically eccentric, right? So you're not gonna be able to pull it out like on the multifunction valves on a R90 pump or 90R pump or 90L pump. This set screw, you can spin it 360. As you spin it 360, if you keep spinning it, you're gonna see that then if it is on the thrust and pullback, you're gonna see your carriage is gonna start creeping back and then going pulling back faster, because you're changing the angle of the swash plate. You're taking it out of neutral. But if you go the opposite, if you tighten it, if you go in the right direction, you're gonna increase it, and you're gonna take it also out of neutral, and then your carriage is gonna go forward by itself. So if you have a carriage that goes forward by itself or creeps forward without touching the joysticks, this is what you gotta adjust. Also put a gauge, because you gotta see that you're neutral. Make sure your neutral is accurate, because you gotta put a gauge on this port and a gauge on this port, and make sure that you're here. Let's say an example, 100 psi and 100 psi. You gotta use two gauges. Some people are like, no, I can do it by eye. Well, the carriage is not moving anymore. Okay. But if you want to do it professionally and accurately, two gauges. Keep an eye on this one and keep an eye on this one. Once you see that both gauges equalizes, giving you the right pressure, that's it. And you're going to see that your carriage is not going to move anymore. And you're going to see, wait a minute. Okay, that's why I'm getting 420 PSI and not 375. Because this one is giving me 100, but this one is giving me 200. Now I know why on the display I have more charge pressure on the thrust and pullback than the rotation that is giving me accurate charge pressure reading. That's all you gotta do. Doesn't mean that the pump is bad. No, just tweaking it, adjusting it. That's all you gotta do. But it's simple, you know. It's simple. If your carriage or machine is moving by itself, all you gotta do adjust it because it's out of neutral. The swash plate, it's stroking, it's sending pressure, and that pressure gotta go somewhere, right? So on a thrust and pullback, once you start the machine, right, and you enable it, you're gonna see the carriage maybe creeping forward, or the rotation, spinning either clockwise or counterclockwise slowly. All you gotta do on Daytrish, American Auger, Vermeer, Toro, Aspen, on any system that uses a setup like this, center the pump. That's it. Doesn't mean that the pump is bad. Doesn't mean that there's anything wrong. Maybe just a simple adjustment. Now, what happens if all of a sudden you lose pressure? And well, not lose pressure. Let's say that this one now is giving you 80 psi. 80 psi, and this one is giving you, I don't know, 60. Right? A high idle. Well, that's concerning. And you go to the relief valve, you try to crank it in, tighten it, bury that set screw, and you see that it jumps from 80 maybe to 120, and this one from 60 maybe to 115, right? This one. So now what you gotta do is, remember what I said in the beginning, that you have your engine. And underneath the alternator, let me put this here. Alternator, right here. You have your double section gear pump. You gotta go here. You gotta go there. You gotta go here and inspect the integrity and condition of the pump, because they do wear out. You have gear meshing with each other. Lack of lubrication wears out the pump. Water intrusion wears out the pump, damages the pump. It's an aluminum housing, but they do wear out. So put a flow meter so you can read how many GPMs you're getting. Because if it calls, if the manufacturer, if Casapa, most of the pumps, these pumps are, or Eaton, they call out for, I don't know, let me say an example, 18 GPM, right? 18 gallons per minute, and you're only getting 6 GPM when you put a flow meter, then you have an issue in the pump. Probably worn out. Simple. That's why you're not getting your charge pressure that is supposed to get after you went through all the process. You need to have a flow meter so you can read GPMs. You're gonna tee it off from the pump, right, on the line to the tandem pump or the pump itself. This is not gonna lie, because if it calls out for 18 GPMs and you're getting 6 only, then you have an issue on the pump, on that pump. Some people, they like to disassemble the pump, inspect them, right? Which is okay. I do that because I want to know why am I getting 6 GPMs? I already know that I have an issue on the pump. So let me remove it, open it up, and see what happened, because I gotta find out what happened, right? But when I open it up, you're gonna have sections. You're gonna have a plate here, a plate in between, and then some other plates. They're all aluminum. When you open it up and remove the gears, you're gonna see that inside the housing is wore out. You're gonna see that it's scraped off, because inside that double gear pump, you have let me put it like this, right? You have gears big enough so you guys can see it, right? Something like that. Anyway, you're gonna have gears, right? And this gear, you're gonna have another one, right here, that meshes with this one, right? With this one. Here, you're gonna have, it goes like this, it goes like this, and it goes like this, right? You're gonna have, let me erase this. You're gonna have a plate with seals. You're gonna have a seal that looks like this, right? And then you're gonna have a backup ring, a clear backup ring that also has the same shape, and you gotta stack them up. Also, back on the bottom, and you're gonna have them also the same plate that you have here. You're gonna have it also over here, right? With the same packing that it looks like this, something like this, like that, right? Like that, right? Like that. Depending on how many sections the pump has, you're gonna have more of these plates, stack them up. So when you open up the housing, you're gonna see that it's gonna be worn out around here, right? Let's say that this is, just for reference, let's say that this is the housing, right? Let's say that that's the housing. When you disassemble everything and you look at the housing, you're gonna see scrape marks around here. Why is that? Why do I have scrape marks inside the housing? Specifically on this section, right here, and right here. Why? What happened here? Why do I have those scrape marks inside the aluminum housing? You want to know why? I'll tell you why. Because this place right here, they move up a little bit and move down a little bit. The whole plate move up. The whole plate. This one, yeah. This whole plate moves up and down. That's why you have scrape marks right here. Because it expands and retract. This place right here. This one's. That the shaft of the gear goes through. That they have inserts right here that are brass inserts. Right here for the shaft. That's why you have scrape marks. So if you're already getting, it goes out for 18 GPM, and you're only getting 6 GPM, you know what I would do with this pump? Toss it away. Garbage. Being honest, garbage. There is no way you're gonna be able to save this. There is no way. That's already done. That's already gone. There is no way. You can put new packings. You can change the gears, right? But you're not gonna do anything. You're gonna end up with the same issue because now you're having leakage around here. You're having leakage around here, and that's why you're not getting your 18 gallons per minute. So if that's your situation, you gotta get a new pump. Now I heard and I've seen people that have called me and say, "Hey man, you know what? I'm still having this issue. You know, I don't know what to do. You know." And when I ask them, because I gotta ask questions, because if they're asking for my help, I gotta ask questions so I can have a better understanding of the issue, not to make them feel bad, just to understand them and give them the proper guidance, you know, and right diagnostic. Like when you go to the doctor, right? You feel bad, doctor gotta ask you questions to know what medication I prescribe you. Same thing. It's the same thing. I heard people say, "Hey, you know what? I use I took the gear, you know, the gears, right? The original gears, right? Took the original gears, put them right here, right? So it's the original gears. They are meshing perfectly, right? Meshing perfectly. And I use, you know, all the internals, even new packings, you know, the packings that goes here, that goes here, that goes here on the bottom, here, whatever, all the packings, or everything original from the previous pump, because the housing, you know, had scratch marks inside, deep scratch marks, and or even wider scratch marks. Man, but I'm having the same issue. Of course, you're gonna have the same issue because this plate over here already worn out, also from the previous housing, and you're still having leakage around here. Around here, still having leakage. Of course, you're gonna have the same issue. That's why I say I will toss away the pump. There's nothing that I can do. So trying to mix match used parts with new parts, especially on an aluminum pump housing like this one, gear pump, you're gonna waste time and money. All the money that you're gonna spend and all the time that you're gonna spend trying to make this work, you know, it's gonna cost you more than getting a new pump and throwing it there. And these pumps you can get them, you know, reasonable prices, different sites, you know, suppliers. All you gotta do is do your shopping around. You're gonna find them, you know, competitors, different prices. But yeah, that's why you still have the same issue. You did nothing. You just transfer the old problem to the new pump, to the new housing. That's all you did. And then you might be like, man, you know what? So it wasn't the pump. Because look, I used the original parts on a new housing and I'm still having the same issue. Right? And then you end up disassembling the whole hydro system. You end up disassembling the whole hydraulic system. And you're gonna, I've heard people, no, you know what? It wasn't that. I put a new pump. What do you mean a new pump? Because if you replace the whole pump, you're not gonna have that issue anymore. Oh no, this is what I did. I took the inners, the gears, and the plates. I put new packings into a new housing. Of course, you're gonna have the same issue. you're gonna have the same issue because those plates that slide up and down a little bit, they're already worn out. Also, you gotta buy a new system, a new pump, a new tandem gear pump, and your issue is gonna be gone. But if you don't know what you're doing and you don't do your troubleshooting with the proper tools, they're expensive. Yes, they are. Hydraulic flow meter, yeah, they're pricey. Hydro gauges, you can get reasonable ones and expensive ones. But if you don't get the proper equipment to troubleshoot, you're gonna waste time and money. And then the easiest route to go and say is that no, you know what? Is the design. Is the design. No, it's not the design. Is that maybe you don't understand what you're doing? Is that maybe, you were trying to cut corners by, no, you know what? I can fix it right away. No, it's because the easiest route to, no, it's a faulty one. It's the quality. No, not always. Not always. Is that maybe you don't know what you're doing? And I say this respectfully, on a way that maybe understand the system and think, is it okay if I use new parts on this housing? Am I gonna have the same issue? Am I gonna ended up wasting precious time and money to the owner of the equipment or to my company? Yeah. It's just asking. Ask anything, anything, any question. But what about this? If you ask so many questions to a technician, he can't give you a straight answer, then that's a red flag. Well, I think it's this. No, 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 no. I think it's not. It's not enough for me. I think it's like, well, 50-50. No, no, no. Either it's 100% or you don't know or you're not sure. You're not sure? Okay, no worries. Thanks for your help. I'll go somewhere else. Oh no, I think it's this, but wait a minute. You did this? Did you check this? You check that? Well, if they gave you a vague answer, then no. Then no. You gotta be 100% sure. And if you own the equipment, it is your right to ask all the questions. If it bothers whoever's fixing it, well, too bad. I'm the one paying you. I'm the one paying you. So I have the right to ask all the questions because it's my equipment. I'm the one doing the expense. I'm paying you for the labor. Or if he's buying the parts, whatever. But no, ask every single question. There is no stupid questions. There is no stupid questions. And that's what I believe, and that's how I am. No, okay, what question do you have? Let me break it down for you. This is how I work. And I'm gonna give you a simple explanation because I don't want to lose you with technical information that maybe you're not gonna understand. You're gonna, be leaving confused. No. Let me explain it on a layman's way, on an easier way, that is easier for you to see it, to break it down and process it. That way, when you have an issue, you can be like on a different equipment. Wait, this is what happened. Same symptom, same issue. It has to be this because I already experienced it with the other equipment, and my technician took me step by step and explained to me why it failed, what needed to be changed, and how it got fixed. In my work, when I'm doing any single equipment repair, If I gotta write down an encyclopedia of information, I will write it down. I don't care. I'm getting paid. The more information I give out, the better. For example, I might use R&R, remove and replace this component because of found that it was worn out. Supposed to have 18 gallons per minute. It was giving me 6. After putting a flow meter, that's what I came across, that it wasn't putting out the necessary flow, starving the charge pressure system, and so on. That way, the owner of the equipment or the company that you work for, whatever, can have all the information. That's what makes the difference between a professional and a parts changer. Going to the root of the problem, to the source, given an exact, thorough information. I do a lot of warranty work. And, owners ask me, hey, what were your findings? Here's the report. Every single detail. And I show proof. I'm going to show you the old part, how damaged it was. And I'm going to show you the new part. If I got to take a video, I will take a video of the process. Be like, here. Because I've seen videos. No, I'm changing this part of the pump because this thing does this and this thing does that. Okay, but does what? You didn't say anything. You just say does this and it does that. What? What is it doing? So, oh yeah, no. If I own the equipment and I'm paying you, I expect a full, thorough report. And don't get offended if I ask you for, okay, let me see the old parts. I want to see them, or save them for me. I'm paying you. So that's how I am with, with everything that I touch. I take a video of the before, symptoms, reactions, step by step, and give my suggestion, professional guidance and opinion about how to proceed and how to fix it properly. And according to the okay, then I proceed through the whole process. And I take a video of the final product, of the final equipment or component working. That way, everything is recorded, written and video. Because, it's money. And things now are really expensive. So that's why I have a lot of passion, because before I was a owner-operator. I had my own business. And, things in life change, that I had to take a different route. We all do in life. So I had to readjust and do some other stuff. But my passion for it, I keep doing that. Fixing heavy equipment, troubleshooting, rebuilding it. That's what I do. And you guys that are seeing me, know me, and see my finished products. And see my videos that I have posted before. And you've seen in person my work. And when I see the big smile, and how confident they are on their equipment, makes me the happiest person ever. That's why I believe on helping others. Because if I know people that they want to go get into the business and they have to put a lien in their home, sacrifice a lot of stuff, and then things break, equipment fails, take it to the wrong person, and then everything from there on starts going downhill. Then they lose everything. No, if I gotta give a helping hand, I will give it. Why not? If God gave me a privilege of having this ability and knowledge, why not paying it forward? Hey, why not paying it forward, man? Came to this world with nothing. I'm leaving with nothing. So that's where I stand. That's my beliefs, and if I gotta pay it forward, why not? Because I've seen the struggles. I live the struggles. I've been on that side also. But it gives me a lot of satisfaction helping people. Giving them guidance and help. That's me. If you ask me for guidance, suggestions, or help, yeah, I will help you. But I think that it's just about being careful because, like I said, parts right now are so expensive that it's crazy. It is so crazy, and then taking it to, no, this guy said he can do it for me, for less, and he already knows the problem. Okay, well, and then they come back, hey, you know what, man, still having the same issue, and I thought that he knew what he was doing. Well, maybe by having a simple conversation from the beginning, you should know. Should give you a red flag. How can he diagnose the equipment, the system, without using the proper equipment? Without saying, oh, you know what? I put a gauge on it. I did this test. I did this test. I put a flow meter. I uh, did this, did that. Okay. According to this is what it is for sure. Do you want me to repair it? Yes. Okay. Then, unfortunately, I open it up. Pump is wasted. It's garbage. It's gonna cost you the pump $1,000 because that's how much things are. $1,000. Okay, go with it. All right. Put it back. It works. That's the process. But seeing the machine, oh yeah, it's this. What? How can you tell? You might have the same symptom, but does not mean that is the same as the other machine because it could be something different that might look the same. Anyway, so what I'm trying to say is that doing things properly, saves a lot of time and money. And yeah, I love teaching. I love showing how to fix stuff, helping people. And yeah, I love tools. And like I said, you don't have to spend a lot of money on tools, just to do things right. The tools don't define the mechanic. Tools do not define the mechanic because you have a lot of tools. You can have all the tools in the world, but if you don't know how to use them, it's worthless. You can have the most expensive brand of tools. That does not mean that you're the best mechanic. You might impress people by, wow, man, you know what? He got so many tools, expensive tools, but does he knows how to use them? Does he knows how to fix the equipment? But it's worthless. So you can have cheap tools. But the quality is different, yeah. It varies. Do they help you do your job? Yeah. Hey, it's okay. I rather, uh, I have all brands of tools, to be honest with you guys. All brands of tools. Because, hey, if it helps me do the job, okay. That is not a high-end brand name tool, okay. If I wanted to buy the tool, it's gonna cost me, $500, and I got it for 120, cheaper version, same tool. Hey, better for me. So it's not the tools what defines the mechanic. It's the knowledge and knowing how to use the tool and understanding, how a system reacts, how a system behaves, how a system is supposed to work, and listening, you know. But yeah, on Yeah, and that's what makes the difference. That's what makes the difference. Um, well, guys, I want to say thank you for staying with me during this brief explanation. I try to be simple, explain things, and break it down on a more understandable way possible. I hope I was able to do that because I don't want to do too technical because then it might be confusing. You know, I just want to be able to make you guys feel like you can relate, to what I'm explaining, and you can understand it. Because sometimes, in the technical field, they use so many big words, and what can you just say it some on a simpler way, you know? So because going too technical lose might lose the idea, or might lose the attention, or might go a different way. You don't want to lose. I don't want to lose anybody. I want to keep it simple, so that way, next time they go through an issue, be like, oh yeah, I remember. So but thank you anyways for joining me for this live. Like I said, I'm going live through YouTube. If you like, please click and follow and subscribe. I'm gonna be doing more videos like this. I've been doing some. I might have some guests joining me that we're gonna be talking about tools, about experiences in life, race cars, um, and all that kind of stuff. My background, a lot of people don't know. They think that I'm just turning wrenches, but I was part of the top alcohol funny cars and dragsters in Puerto Rico back in the early 90s with Budweiser and the team Budweiser and Skull Bandit and funny cars and dragsters. So yeah, that was my background. Uh, you know, so yeah, knowledge I do have. I've been in places. I study a lot, and when I hear people giving me their own version or their explanation, just inside of me, I'm like, what? No. So yeah, been turning wrenches for a long, long time. Was part of the in Puerto Rico, of the dragster with a well-known person that unfortunately passed away a few years ago. He owned the Budweiser dragster and funny car and the Skull Bandit. Um, he was a great guy, but he taught me a lot also. Or when I was going through college and school for industrial, technical, mechanic. So yeah, I just stay quiet when I hear gibberish. I'm like, wow. Anyways, that's not the point. The point is that I'm sharing here, sitting in front of you guys with proper knowledge, and yeah. So please join, click and subscribe, and follow me for more. It'll be until next time, guys. So have a good night. Bye.